I'd like you to imagine that you and I are at the office and we're having lunch and our boss rushes in and says, hey, I just read an article that talks about CAM table overflow attacks that are causing a loss of confidentiality because the attackers can now eavesdrop and watch every single frame on a VLAN. And what we could do is smile at each other and then turn to the boss and say, you know what, no worries. We've already mitigated that threat by using a feature of port security. And so in this nugget, you and I are going to talk about some of those details regarding port security and how it can protect against that type of an attack. Let's begin. Say hello to my little friend. This is a Raspberry Pi that earlier today I configured with Kali Linux. Now, the actual Raspberry Pi itself is around $35. And what I did, I added this little SD card, which acts as its hard drive. And I added this little wireless adapter, which was about 15 bucks. So all told, I probably spent around $65 on it, as you see it configured right here. I had an Ethernet cable already. And what I did, I took this Ethernet cable and I plugged it into a switch port. Now, if you haven't yet seen Kali Linux or Backtrack, you may want to check out the Penetration Testing Tools course right here at CBT Nuggets. And the flavor of Kali Linux that installs on a Raspberry Pi is very minimized. It doesn't have all the tools that the regular Kali Linux distribution has. So what I did was I used apt-get and I installed the dsniff suite, which includes something called mac-off or mac-off, however you want to pronounce that. And then I ran mac-off. And what this does is sends in thousands and thousands of frames into the switch, and it makes up a bogus MAC address for every single one of those frames it's sending in. So this poor switch port right here is now memorizing or trying to memorize all these brand new MAC addresses. Now at some point, and on many switches, a switch might support, for example, 5,000 MAC addresses in the content addressable memory. That's where it stores MAC addresses that are dynamically learned. And what happens if we pump in 6,000 or 7,000 or 8,000 bogus made-up source MAC addresses into that port on the switch? Well, at some point, the switch is not going to have room for everything. And the intent with a CAM table overflow attack is to have the switch be bombarded with so many brand new MAC addresses that it forgets about the real device MAC addresses. So maybe here on this switch, we have PC1, and on this port we have PC2, and they're happily talking to each other. And let's say that the Kali Linux box is plugged in right here. And it doesn't have to be Kali. It could be any device that's running mac-off or a similar utility, sending tens of thousands of frames into the network with bogus source MAC addresses. So in this VLAN, as the switch forgets about PC1 and PC2 because of all the new MAC addresses it's learning from the Kali box, the traffic between PC1 and PC2, which would normally be switched at layer 2 based on the destination layer 2 frames, now that the switch no longer remembers PC1 or PC2's MAC address, when the switch receives a frame and it's not in the CAM table, the content addressable memory, the switch is going to treat that frame as an unknown, and it's going to forward that frame to all other ports in that same VLAN. And that gives the opportunity for this device, the Kali device, to now eavesdrop on the conversations that are happening in that VLAN. And this is a real attack, and it's also really easy to pull off. So that, my friend, is our attack scenario. Now, what can we do to solve this? Well, port security is going to go ahead and save us. Because with port security, we could tell this port on the switch, for example, or this port on the switch, that we want to limit the number of MAC addresses it can learn on that port. For example, we could say 5. 5 is the maximum number of MAC addresses that this port can learn. And then once we exceed the 5 that are showing up on that port, we have several actions that we could take. And the violation actions are PRSS. And these are the first letters of the actions. Now, if you're taking notes, which I hope you are, and I encourage you to do so, let's jot these down together. The first violation action is called protect. Now, what does protect do? Protect says, okay, I've got 5 MAC addresses. That's the limit that I've set. Anytime I see anything more than 5 MAC addresses, I'm not going to, says the switch, I'm not going to let those frames in the network. They're not going to make it. The first 5 I have memorized, they're good, but anything beyond those 5, I'm not going to let in. Now, the problem about the option of protect is that it's a little bit shy. Now, when we think about shy, what does that mean? Well, in the case of protect, it means it doesn't want to tell anybody there's a problem. There's no syslog message, there's no SNMP, there's no alerts. It just kind of sits there and does its job, but doesn't let anybody know. And that's why we're very likely not going to want to use protect as the violation action, because we want to know about it. We want to get a syslog message. We want SNMP messages. And protect doesn't give it to us. The next option is restrict. Let's write this one out together too. And restrict does the same thing that protect does, except it's all about sending alerts and messages. So there's SNMP if you have it configured. There's syslog. The counters are going to increase every time there's a violation. And we want that information. We want to know that something's happening on our network, like an attack, like a CAM table overflow attack. So that's why we would likely use restrict instead of protect. And check this out. Not every single Cisco switch supports all of these features. We might have some switches that only support 2 of these violation actions. We might have some that support 3 and some that support 4. So depending on your hardware and the switch that you're currently on, it's possible that your switch might support 2, 3, or all 4 of these options. Now the next option, the S, happens to be the default. So I'm going to put a little asterisk next to that. And the S is for shut down the port. So it goes like this. If the maximum setting is 5 that we set it to, and that 6th MAC address as a source MAC address shows up on the port, boom, the port is brought down. It also is going to talk about it. So there's going to be SNMP, syslog, counters that are generated with that event as well. And this last S also happens to be for shutdown, but it's not shut down for the interface, it's shut down for the VLAN. And that's pretty drastic, shutting down the entire VLAN, saying, everybody stop the truck, nobody talks in this VLAN, as opposed to just shutting down the port. So the default behavior is to shut down the port if there's a port security violation, and the default maximum number of MAC addresses, once we enable port security, is 1, which means the second MAC address that shows up at the same time on that port is going to go ahead and trigger a security violation for port security if we're using the default number of 1. Now with port security, we have 3 modes that we can play with. We have dynamic, static, and sticky, which is just a lot of fun to think about. So with dynamic, it's exactly what it sounds like. MAC addresses are simply learned dynamically as devices connect and send a frame into that switch port. So if PC1 sends a frame into the switch port, the very first frame, the switch dynamically learns that MAC address, and if this is a secure port because of port security, we now have a dynamically learned secure MAC address on that port. The next option is static. Now, what does static sound like? Well, Keith, it sounds like we're statically putting in a MAC address. That's exactly what it is. Static is where you and I go to a switch port and say, this is the MAC address that lives on this port. So, for example, if we enable port security and we have a default maximum of 1 MAC address, and we statically configure that MAC address, any other MAC address that shows up on that port is going to cause a port security violation. Now, on the other hand, if we statically configure 1 MAC address on a port and we set the maximum to 5, that means we could still dynamically learn 4 more MAC addresses and still be within tolerance. It's that 6th MAC address, if our maximum is 5, that's going to tip the scale and set off a violation. Now, I have a question for you. Let's say you and I do configure a static MAC address for port security on this port where PC1 is. So I'd like you to imagine typing the commands in to go ahead and configure static port security. And we'll demo that here in just a moment. And here's my question for you. As we press enter after we put in that configuration, where is that configuration stored? And you might say, well, Keith, here's how it works. Once we type something in and press enter, that is stored in the running configuration. Absolutely correct. So if we configure a static MAC address, it's in the running config because we put it there. And the second question is, how do we get the running config copied over to the startup config? And you might say, well, Keith, we can do a WR command or a WR mem or a copy run space start, which is short for copy running config to startup config. Any of these options of saving our running configuration to the startup config is fantastic for getting a static MAC address into NVRAM or into the startup configuration. And for the last option, I'd like you to imagine a scenario where we have 100 PCs brand new on a brand new network. And they've asked us to hard code those MAC addresses into the configuration on the switches. Oh, that sounds painful. We'd have to first of all find out what those MAC addresses are and then configure them as static MAC addresses. Well, the sticky option actually can save us some time. With sticky, what it's going to do for us if we configure the sticky option for port security is it will take any dynamically learned MAC addresses and it will automatically put them in the running config for us, saving us that step. So in that case, all we'd have to do is configure the 100 ports where those 100 PCs are connected as port security with the option of sticky, turn on all the PCs so they send at least one frame into the network. The switch would then dynamically learn those MAC addresses and it would be in the running config for us. Now that's most of the battle. The last step would be to take our running config, and thanks to sticky, the dynamically learned MAC addresses are now part of the running config, and copy that over to startup config. And once we have copied it over to startup config, the next time the switches boot up, guess what? They'll have those MAC addresses configured in them as sticky learned MAC addresses. So that's how sticky is going to help us in getting MAC addresses dynamically entered into the running config, and then manually we would follow it up with a copy run start to move them over to the startup config. Now with port security, we can set it up on an access port or a trunk port, but it does have to be a static access port or a static trunk port. Port security does not work on a port that is a dynamic port, a port that's willing to go either way. I'll go access or I'll go trunk. It needs to be configured either as an access port or a trunk port if you want port security to be used. Now, if we are configuring a trunk port, we want to be aware that we might have thousands and thousands of MAC addresses all coming over that trunk. So in addition, on a trunk port, we also might want to include some options for specific VLANs. For example, we could say in a trunk port, I want the maximum number for VLAN 123 to be 50 MAC addresses or 100 MAC addresses. Or I want to do a static MAC address for a specific VLAN. So just be aware that when you're doing trunk configuration for port security, we do have options for adding details regarding specific VLANs so that we can implement the control we want to. For example, we may want to do port security limiting of 50 MAC addresses for VLAN 123 and maybe 500 MAC addresses for some other VLAN. And we can do that by including the VLAN information, the VLAN keyword, in our configurations when we're dealing with a trunk interface. There's also some options with port security for aging. For example, if we're doing dynamic learning, do we want to age those MAC addresses out of the CAM table as secure MAC addresses based on inactivity timeouts or based on an absolute timeout? Those are some additional options we have when setting up port security. It's now time for our assessment check. Go ahead and take a moment, answer these questions, and then we'll review them together. Good luck. Well, my friend, how did you do? Let's take a look. How many MAC addresses are allowed by default regarding port security? And the answer for that is numero uno, just one by default. Question number 2, what is the default violation action? Is it protect? Is it restrict? Is it shut down the port or shut down the VLAN? And the answer is yes. It is one of those. It is shut down the port. It'll put the port into an error disabled state when a violation occurs. That is the default violation action, is to shut down the port. Question number 3, which attack can be prevented if we implement port security? And the attack that we mentioned in this nugget is a CAM table overflow attack that we can mitigate and reduce the risk of that happening by implementing port security. And then question number 4, when will we go through the demonstration for implementing port security? And that, my friend, is in the very next nugget. So now if our boss approaches us and is worried about, oh my goodness, I heard about these CAM table overflow attacks and hackers eavesdropping on all the frames, we can say, you know what? No worries. We can mitigate that using a feature called port security. Hey, thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.